Introduction. Electricity is a form of energy. It is very useful as it can be converted into many forms of energy such as heat energy, light energy, mechanical energy, sound energy, etc. Electricity is used to run many electrical appliances in our day-to-day life, which makes our work easier. Electricity is used for lighting purposes. Electricity makes it possible to light up our homes, offices, markets, roads, and factories. Electricity is used to run many appliances like fans, coolers, air conditioners, room heater, electric motor, etc. A power station provides us with electricity. In this chapter, we will learn more about electricity. Electric cell. An electric cell is a device which produces a small amount of electricity. It is a source of safe and portable electricity. A cell in a cylindrical device having a small metal cap on one side and a metal disc on the other side. The electric cell has two terminals, a positive terminal and a negative terminal. The metal cap is positive terminal of electric cell and metal disc is the negative terminal of the electric cell. The positive terminal of electric cell is marked as plus, whereas the negative terminal of electric cell is marked as minus. An electric cell has a number of chemicals stored in it. The electric cell produces electricity from the chemicals stored inside it. When all the chemicals in the electric cell are used up, the electric cell stops working and produces no electricity. It is then replaced with a new one. Generally, dry cells are used.
In appliances like heaters, iron, etc., heating effects of electric current is used. All the appliances contain a coil of wire known as element. When an appliance is connected to electric supply, its element is heated and becomes red hot. The amount of heat produced depends on its material, length, and thickness. Thus, for different requirements, wires of different materials and different lengths and thickness are used. An electric bulb also works on heating effects of electric current. It gives heat along with light. This causes wastage of energy. This wastage can be reduced by using fluorescent tube lights in place of the bulbs. Compact fluorescent lamps, CFLs, are used.
Torch bulb. A torch bulb has a small electric bulb which produces light when a torch is switched on. A torch bulb consists of a small glass bulb fixed on a metal case. Inside the glass bulb, there is a very thin wire fixed between two thick wires. This thin wire is called filament. The two thick wires inside the glass bulb provide support to the filament and also makes connection of the filament to the outer circuit. The lower end of one of the thick wires is connected to the metal tip at the bottom of the bulb, whereas lower end of the other thick wire is connected to the metal case of the bulb. The metal tip at the base of the bulb and metal base of the cup are two terminals of the torch bulb. Thus, a bulb has two terminals. The two terminals of the bulb do not touch each other. They are separated by an insulating material between them. When two terminals of a cell are connected to the two terminals of a torch bulb by using wires, the electric current passes through the filament of the bulb and it starts glowing. When electricity from the cell passes through the filament of the bulb, the filament gets heated too much. The filament becomes too hot and starts giving light. A torch bulb converts electricity into light. A bulb connected to an electric cell. Activity: take 4 lengths of electric wire with differently colored plastic coverings. Remove a little of the plastic covering from each length of the wire at the ends. Fix the exposed parts of 2 wires to the cell and the other 2 of the bulb. Stick the wires to the bulb with a tape. Now connect the wires fixed to the bulb with those attached to the cell in 6 different ways. For each arrangement, find out whether the bulb glows or not. An electric circuit. An electric circuit is a path along with which electricity can flow. The electric circuit provides a complete path of electricity between 2 terminals of the electric cell. The bulb glows only when current flows through the circuit. The electrical circuit in which there is no gap in the connections between the terminals of the cell, wires and bulb, etc. is called complete circuit or closed circuit. In an electric circuit, the direction of flow of electricity is taken to be from the positive terminal of the cell to the negative terminal of the cell. Electricity flows through closed circuit. The electric circuit where there is a gap between the terminals of the cell, wires and the bulb, etc. is called an open circuit. Electricity does not flow through open circuit. Electric switch. A switch is a simple device which is used to open or close a circuit. A switch works by opening or closing a gap in an electric circuit. When the switch is in the off position, a gap opens up in the circuit due to which electricity stops flowing in the circuit. Hence, the electrical appliances stop working. When the switch is turned on, the gap in the circuit is closed and a complete circuit is made and electricity starts flowing. Some of the appliances which have inbuilt switches are table fan, room heater, room cooler, mixer, grinder, table lamp, etc. Activity 1. Insert a drawing pin into the small ring at one end of the safety pin and fix it on the thermocol sheet. Make sure that the safety pin can rotate freely around the fixed drawing pin. Also tie one end of a piece of wire around the drawing pin. Now fix the second drawing pin on the thermocol sheet at such a distance from the first drawing pin that the free end of safety pins can touch it. When the safety pin is turned, a piece of wire is also tied around the second drawing pin. So, we have a safety pin whose one end is fixed in a drawing pin and other end is free to turn so as to touch the second drawing pin. When the safety pin is arranged in the way is connected in a circuit, it behaves like a switch to open and close the circuit as desired. Now, set the circuit as shown. There is a gap between the ends of safety pins and second drawing pin. The circuit is open and hence no current can flow. When we rotate the safety pin and bring its free end in contact with the second drawing pin, then the gap in the circuit is closed. The switch is now in on position. Since the circuit is now complete, current will flow. Again, we can bring the switch in off position by removing the safety pin away from the second drawing pin. Electric conductors and insulators. Those materials which allow electric current to pass through them are called. The flow of electric current is called electricity. All the metals are conductors of electricity. Silver is the best conductor of electricity. Those materials which do not allow electric current to pass through them are called insulators. Insulators are actually non-conductors of electricity. Rubber, plastics, glass, mica, cotton, jute, wax, paper, etc. They do not allow electric current to pass through them. For this reason, outer covering of electric wires is made up of plastic because it is a poor conductor of electricity. Conductors are used to carry electricity. Insulators are used for safety. Insulators protect us from getting electric shocks. Insulators allow us to handle current-carrying wires, switches, plugs, sockets, and other electrical appliances. Activity: take a cell torch bulb fitted in holder and some connecting wires with crocodile clips and connect them as shown. A gap is left between the ends of crocodile clips A and B, so no electricity flows in this open circuit and hence the bulb does not light up in this case. The arrangement is known as conduction tester. Now insert a paper clip made up of steel in the gap between the free ends of the crocodile clips A and B to complete the circuit. Bulb will light up. This means that paper clips steel is conductor of electricity. Remove the steel paper clip and connect a pencil in the gaps between the crocodile clips A and B. Bulb will again light up. This means that graphite is a good conductor of electricity. Now connect eraser, a plastic scale, a matchstick and a piece of a paper between the crocodile clips A and B and check whether bulb is glowing. If the bulb glows, it is a conductor, and if bulb does not glow, then the substance is an insulator. Some important points. An electric cell is a device that converts chemical energy into electrical energy. It has two metal plates indicating two terminals, negative and positive. It has chemical inside it. Arrangement that provides a complete path for electricity to pass, current to flow, is known as electric circuit. When the two terminals of the bulb are connected with that of electric cell by wires, a current passes through the filament of the bulb and it makes the bulb glow. The simple device that either breaks the circuit or completes it is called switch. Materials that allow electric current to pass through them are called conductors. For example, iron, copper, etc. Metals are good conductors. Materials that do not allow electric current to pass through them are called insulators. For example, rubber, plastic, etc. Rubbers and plastic are used to cover electric wires and plug tops because they are insulators and do not allow electric current to pass when we touch plugs and switches.